All right, you are welcome to the GMAETS 41's live class. In this particular class, I'll be putting you through the concept of solubility of organic compounds. Solubility of organic compounds. Now, this particular class is connected to UNIZIK chemistry practical for second semester, Chem 108. All right, and we shall analyze chapter 3 of this practical work. It is based on solubility of organic compounds. So once again, I say welcome to you, friends. If you are yet to subscribe to this wonderful channel, please right away hit the subscription icon. Okay, hit the subscription icon, and without delay turn on the notification bell, so that once I upload any video anytime, maybe a pre-recorded video, because many of them are always being uploaded, or perhaps we have live class like this particular one, you will be personally notified by YouTube. And as we get ready to move on into this analysis, I'd like to continue to encourage you guys, my friends there, in UNIZIK, always make sure you make good use of your time. Let me ask this question. Are you in lecture hall now? Perhaps maybe you are supposed to have lecture right away. Is that lecture going to hold? I don't know. I am not there, right? But let us assume for any reason the class is not holding. What will you be doing with your time? Will you continue to complain, sit back there doing nothing, wait until endless time, and then get your stuffs, go back home? A wasted day. Is that what you're going to do? GMAETS 41 has always encouraged students on the need for adopting online learning. Very important. So GMAETS 41 operate both physically, all right, on campus. I hold tutorials for you guys on campus, those in UNIZIK. And then online, I still remain committed to giving you guys the best. Chemistry practical Chem 101, solubility test of organic compounds. If you check your manual, practical manual in chemistry, you'll agree with me that this is, I think, chapter 3 of the work. Okay, and so you are expected to learn the concept of solubility of organic compounds in certain solvents, reagents. Okay, so I've got this particular question that I want us to consider. Let us look at this particular question. Of course, this week, at least I am aware that you friends are working on this particular experiment, solubility test. So I have this particular question. I'm going to dictate the question. Now, when I dictate it, the focus of this particular live class is not to assume anything you are going to do in the lab per se, but to give a summary, a powerful lecture, a classical analysis regarding what, as a student, you expect to know when you are dealing with solubility test, and with what you are going to learn from the class, whatever, like what you're going to learn from this particular class, whatever you meet in that laboratory, you can analyze it 1 + 1 and perform excellently well. So make sure you follow up with this class as I kick it off. I have this question. Experiment 3, sample A and B are two classes of organic compounds. Sample A and B are two classes of organic compounds. Okay? A. Perform water solubility test on them to indicate if it is a polar or non-polar compound. B. Classify if the organic compounds given are neutral, acidic, or alkaline using a pH indicator. C. Using 5% sodium hydroxide, 5% sodium hydrogen trioxocarbonate 4, 5% hydrochloric acid, and tetraoxosulfate 6 to determine their solubilities and suggest their functional groups. So that is the question. Some of you already have this preview of this particular solubility test. So this is what we are going to do. It is expected that in your laboratory work, you will be presented with perhaps two organic compounds. We assume that they are different, supposedly, yes. Now, these two organic compounds, they belong to different classes of organic compounds. That is why you study the concept of functional groups, which, of course, in our physical tutorial and in the GMAT 41's online tutorial, in your Chem 102, Basic Organic Chemistry, I had taught that concept of functional group. There are about 14 of the functional groups you are expected to know, such that if I write a particular functional group, you look at it, you can tell me that this is this formula, this compound. You should be able to do that. And of course, like I mentioned in one of my previous class, when I was teaching IUPAC nomenclature, I stated that you see your Chem 102 is very much connected to your Chem 108. There are so many knowledge, idea that you pick from that Chem 102, which is your theoretical work you do in your lecture hall. You apply those things in your Chem 108, which is the practical stuff you do in your laboratory. So like I say, A and B, there are two classes of organic compounds. We are now asked to perform certain tests on them. The first test is to carry out solubility tests on these organic compounds using water. The second aspect, you are expected to test or classify these organic compounds, as to whether they are acidic, basic, or neutral. That one of using water, all right, to test. The aim is for you to state, all right, confirm whether these organic compounds are soluble or insoluble in water. Of course, if that is the case, based on the instruction, you are meant to state whether the organic compound is polar or non-polar. Then next, you are expected to use that aspect where you classify whether a compound is neutral, acidic, or alkaline. You are required to use a pH indicator. Like I said, you are not in the lab. I am not there. Your lab technology is to decide the pH indicator to give to you. It could be litmus paper. In my analysis, I'm going to make use of litmus paper, but it could be exposed to something like maybe using methyl orange or any other pH indicator that helps you to determine whether a particular compound is acidic, basic, or neutral, as the case might be. Whatever you meet there, you work on it. But like I said, this class, I'll be focusing on the use of litmus paper. And I want to believe that some of you, if not all, anyway, let me say all of you have seen your litmus paper before. I've got this. You see the paper inside. Okay, this is, I think, red. Yeah, red litmus. So, you can be given this to carry out your test to classify the two compounds. This one is blue litmus. To classify the two compounds, whether it is acidic, basic, or neutral. So I hope that you are presented with litmus paper. But whatever the case is, even if you are given another pH indicator, I want to advise you now, dear students. That is why you have your online. Google is there for you to check what I'm about to tell you now. Check the color of, methyl orange in acidic medium, in basic medium. Get to know in neutral solution what's going to be the color. What about phenolphthalein? These are also pH indicators. Check the color change of that guy in acid or in basic medium. Check what happens in neutral solution. Because like I said, why this particular class will be based on pH indicator using litmus. Who knows, if you are presented with another pH indicator, you should be able to analyze it. So having said this, the next thing you're expected to do is now to determine and suggest likely what the functional group of A and B will be, or would be rather. Does that make sense? So this is really what you're doing in this solubility test. So we're going to move on right away. Like I said, let us see what you are meant to do. I'm giving you a general idea that covers everything. However, the question is being twisted. You will know likely what to do. So I will start by writing tests, as usual, observation, and then you have your inference. Let me abbreviate infer. Okay? So, we did something similar to this concept, right? That was in your Chem 107 last semester. Test, observation, inference. Now, you are going to be exposed to A and B as organic compounds. Here in this class, I am not going to refer to anything as A and B. Generally that compound A and compound B, they are unknown organic compounds, which you are expected to maybe do some works on them and then try to suggest what A and B are. Are you following, right? So we are going to use the general concept of saying that this is an unknown compound. So depending on what will be seen in the observation, that will now help us to make our conclusion, which is under the inference column. So generally we are using unknown. If you're in the laboratory and then you are testing on A, and A is showing the reactions, what I am going to analyze here, that will now help you to know the conclusion to reach, the observations to write. If you're analyzing, carrying out a test on B, if B is behaving in the manner that I am going to deal with here, then you now know what to write as observation and inference for B. So I try to build this whole idea before we can move on into it. It's not just to rush and start doing. I'm not here to do anything as if you know what is going to be the end stuff in the laboratory. Whatever you meet there, you analyze. But what will now guide you is what I am about to do here. That is it. That one is 100% sure. That what I'm about to do here is what will guide you in analyzing this your compound A and B. So moving on with the test with water to determine whether A and B are polar or non-polar compound. So let us assume that you are exposed to this organic compounds A and B. I'm going to just say unknown, right? Unknown organic sample. Unknown organic sample. So like I said, it could be A or B that you are using in your test. Whatever it is, if it is according to the instruction, if it is A, you are carrying out the test on first, it's going to be A. That unknown organic sample will now be A. Then plus water, plus water, plus water. Now we are going to make an assumption. Let us assume that when you added water to sample A or sample B, as the case might be, that is why I told you we shall be using unknown instead of specifying maybe A and B. If I go through calling one A, the other B, it's going to stress us too much. In fact, we will spend a whole lot of time. So let the unknown be any one of them. So based on the observation we are going to see, we'll now know what we are going to write. Okay, so assuming that on adding water to the unknown sample, you observe that the unknown organic sample dissolved. The sample dissolved in water, which is the same as the sample became soluble in water. Then the inference you're going to write is that the unknown organic sample here, which could either be your A or B, as the case might be, is a polar compound. The sample is polar. Why do we make that inference? Polar compounds generally are expected to dissolve in water. Polar compounds generally are expected to dissolve in what? In water. So you take note of that. So if it is A that you added water to, and maybe after stirring you notice that it is dissolved, can I say that A is a polar sample, polar organic compound? You conclude it here. The observation will be that sample A dissolved in water. Let us assume that it is B you added water to. Say that, okay, A did not dissolve, but maybe when you're testing with B, you added water to it and you notice that B dissolved. B became soluble in water. That would be your observation. Your inference will now be that sample B is polar. All right, so this would be, let's label this as number 1. Okay, number 1. Then let us move on to 2. These two I'm going to indicate it as 2A and 2B. Now we are done with, solubility stuff in terms of whether the thing dissolved or not. Okay, I think I need to indicate the second part. Or rather, we'll come to the second part where we assume that the substance did not dissolve. Please take note. Let me quickly say this. The first direction I am taking is the direction where we assume that the sample dissolved. Either A or B, we found out that it dissolved. I'm going to do that analysis. So that suppose you are carrying out the test on A or B, and you now find out that, okay, maybe it is A or B that dissolved, as the case might be. You would have to know what to write. When we are done with this analysis, I will switch over to a case where we assume that the sample did not dissolve. So let's consider this in the case where it dissolved. So in this case, I'm going to write this as 2A. Okay, 2A. 2A. We are going to now consider a case where we are checking for maybe the acidity, the alkalinity, or the neutral nature of the sample. So the unknown sample, we want to check whether it is acidic, neutral, or what? Alkaline in nature. In that case, you'll be using this sample from 1 above. So I'm going to write our solution from 1 above. So I'm going to write solution from 1 above. Solution from 1 above. I advise you to be writing as much as you can, right? Because I'm going to wipe. I'm going to wipe the board so I have enough space. Like I always say, at the end of the lesson, at the end of this live class, a copy of this video lesson will be made available, so you can always come back to check. And I advise you become a channel member, because sometimes maybe you coming back to check, it's possible that YouTube would have locked it, so that if you are not a channel member, you might not be able to access it. To become a channel member, join GMAETS 41 on the platinum level or diamond level. All right, click join, make your payment with your card. Does that make sense? Make sure you have an active card. Good. Then you join. Just 2,000 naira per month on the platinum level, 4,000 naira per month on the diamond level. Any one of them, that is okay by you. Support GMAETS 41 so you get access to all the key lecture videos available on this platform. So solution from 1 above. Now plus pH indicator. pH indicator. Plus pH indicator. Now the pH indicator I'm going to use, I have told you already that I'll be using litmus. I'll be using litmus paper. That's the indicator I'm going to use. That's what I am considering. I've showed you earlier. Okay. So suppose you expose this solution above to a pH indicator, say litmus paper. In that case, you will dip your blue and red litmus paper at once into the solution. Let us assume that the blue litmus turns red. Blue litmus paper turned red. If you observe that the blue litmus paper turned red after dipping the litmus paper, the pH indicator into the solution from this number 1, because there you have a solution now since you've added water. For blue to turn red, that is behavior of acid. That is behavior of what? Acid. Which means that the unknown sample here is acidic. So under the inference, you are going to write sample is acidic. Sample is acidic. Sample is acidic. Now for the sample to be acidic, there is something you want to take note of. We can specify, we can try to kind of suggest likely what that sample is in this case. One can assume carboxylic acid is present. That is to say, the organic compound, the unknown organic compound, which is either A or B. Remember, what you're observing is what will help you to know what to write. If this thing is what is happening with sample A, you'll now be concluding that A is this. A did that, A did that. I don't know if I'm communicating. Like in this case, it's going to be solution from 1 above plus this. Or you can say solution A from 1 above. If it is B, you write solution B from 1 above. Then if you see this observation, this is the inference you're making. Sample is what? Acidic. I could have gone further. I think I would even go further. The fact that this sample is acidic, and we found out from the first test that the sample dissolved. I'm going to tell you the functional group likely that will be present. And the functional group is carboxylic acid. Sample is likely carboxylic acid of low molecular weight. Please permit me to use MW. MW there means low molecular weight. Low molecular weight. So once you see this occur, once you see this observation, let us now assume that you are working with sample A. When you added water, you noticed that the sample dissolved. Sample A dissolved. Then you went ahead to maybe test with litmus paper. You found out that the solution of that sample A turned blue litmus paper to red, but it did not affect the red litmus paper. It turned blue litmus paper to red. Then you conclude simply that sample A is acidic. And like I said, what is likely there is carboxylic acid of low molecular weight, because it is carboxylic acid of low molecular weight that will, first of all, dissolve in water and then go ahead to turn blue litmus paper to red. The carboxylic acid in question here is that which has a low molecular weight. Because the one that has high molecular weight, something else happens. In fact, that one is insoluble. We are coming to that. That one will not dissolve from the first test. Now, if it is sample B that behaved in this manner, maybe from here, sample B plus water, you found out that sample B dissolved. You make this conclusion, it is polar. You now went ahead to test the solution using pH indicator, and you found out that the solution of sample B turned blue litmus paper to red. You now conclude that sample B is acidic sample, or sample B is acidic. Then you proceed. Sample B is likely carboxylic acid of low molecular weight. Remember, like I said, I have told you from the beginning of the class, I am not going to specify any particular sample as if maybe I'm telling you. If I start writing sample A, sample B, and that thing, it's as if I've carried out the experiment in the laboratory, or maybe your lab technologies had already given me the sample. Look at this. Look at, I don't have any link to them. Yes. But the truth of the matter is, whatever you are doing in the laboratory is 100% connected to theory. It is a theory you are going to verify. So first of all, as a student, listen and listen good. You must. You do what? Must understand the theory before you go to the lab to carry out any experiment. That was why you were given one other manual attached to the one you are recording stuff into. So you can go through all those theoretical stuff. You must have the theoretical behavior of these homologs at heart. Know them at heart, so that when you are now running the experiment, whatever you are saying happening will guide you to make your conclusion. We are moving on. This is going to be a bit lengthy class for say, I don't know, but I'm trying to work fast so that we'll round off. I have class with you UNIZIK students, right? Later this evening, we have Chem 102 physical tutorial on campus. Join GMAETS for the ones tutorial. Contact GMAETS on this number. All right, contact GMAETS 41 on that number showing on the on the board, and then get information about our classes. If you wish to join our physical tutorial, of course you have to wish. It's interesting being with GMAETS 41, whether in our physical tutorials or online. Now we move on. Let us now look at 2B. 2B. Now in this case of 2B, let me write something. What we're about to, or let me say something rather. What I'm about to consider in 2B now is, suppose we did not observe this. Let us assume that when we dipped the 2 litmus papers into the solution above, the blue litmus paper did not turn red. Let us now assume that it was the red litmus that was affected, that the red litmus paper turned blue. In that case, you won't make this conclusion anymore. And in that case, you won't write this observation, because what you saw is that the red litmus was affected. It changed from red to blue. So what are you going to write? Which means that the 2B I'm about to consider here is a situation whereby you did not observe this 2A. In that case, you are now going to replace this 2A with 2B. But you still maintain the same numbering, as given maybe in the instruction, or if you are asked to just do the work straight on your own. It will rather now be 2A instead of 2B, because what I'm about to write here will now appear here instead, being that this observation is no longer considered. So, solution from 1 above plus pH indicator. Like I said, we are using litmus paper. So we are now looking at a situation whereby on that sample, the solution of the sample you tested with pH indicator litmus, and then it happened that red litmus paper changed to blue. So you observe that red litmus paper changed to blue. The question now is, what changes red litmus paper to blue? It is an alkaline substance that does that, which simply means that the unknown sample in this case will now be an alkaline substance. So I will write sample is alkaline. Sample is alkaline. Sample is alkaline. And I'm going to tell you something. For the fact that the sample is alkaline, we have a particular homolog, an organic compound that behaves in that way. First, that organic compound is soluble in water, which goes with this first test. Then going further, when you test it with litmus, it will change red litmus paper to blue. What does that? It's usually a mean group of low molecular weight. Once again, a mean group. In your Chem 102, I already taught you that the functional group of that guy is RNH2. That's your amine, right? So what I am now going to do, I can go ahead to give a possible suggestion of what that guy likely is. And that I will write sample is amine. Please manage this. Sample is amine. So what I wrote here is amine of low molecular weight. LMW. I don't know if this is showing. Let me check the camera. But if it is not showing fully, of course, you can follow the explanation I am given. Let me adjust a bit. That's good. Of low molecular weight. So that is what will be present there. Now, let me do some demarcations and see. Let me do some demarcations for you. Good. So let me now link this analysis to what likely you would see in the laboratory. Let us assume that when you added water to sample A dissolved. If it dissolved, you say that in the inference it is a polar substance or a polar organic compound. Then, testing with litmus paper, you found out that solution of that sample A turned red litmus paper to blue. That's what you observed. You write the observation here. You make your conclusion that sample A is alkaline because it is alkaline that changes red litmus paper to blue. And then you can go further to give possible prediction of the homologue, the organic compound that sample A is. You could write sample A is likely a mean of low molecular weight. Reason: a mean of low molecular weight are the homologues known to go through this, observation or reaction. That is good. I know that I cannot be able to manage this part of the board. I cannot. So I don't know if I am to adjust the camera or wipe the other part from the board. Okay, I will adjust the camera. Share this link to your friends so that you can join the class. Take notes. Take notes. You must be able to understand all these theoretical principles before you step your leg into the laboratory. Otherwise, nothing will make sense to you. That is the truth. It is just like in, let's say, in the laboratory, maybe medical lab. You go for malaria test, and then you drop your blood sample. At the end of everything, you go to collect your results, and the lab scientist is telling you, okay, this is your result. We found out that you have malaria. 1 plus, 2 plus, 3 pluses for those that their own have skyrocketed. My question is, does it mean that when they were carrying out the test on your blood, malaria now appeared and say, hey, look at me, I am malaria. I am 1 plus in this person's blood sample. I am 2 pluses or I am 3 pluses. Very funny, right? That is not what happens. That is why you guys go to school. You learn all these things. Okay, if you use a blood sample, expose the blood to a particular reagent. If you see so reaction, it shows that malaria is what is disturbing the patient. That is what happens. You must have all these at heart. And that is why, for example, those in the medical field, you continue to read, to study, to follow up new findings, because it should be here. Even if you don't have all of them here, you should be quick to consult sources. Reputable sources. Yeah, it's not to just go and get anything anyhow, so you don't put the patients in trouble. Consult reputable sources. Okay, I saw this reaction. No, what is it that time that they said if I see so reaction, I should know this is what is there? Okay, it's malaria. No, it's not malaria, it's typhoid. That is what we are doing here. If you don't have that theoretical background, there is no way. There is nothing you can do there. That is why some of you who perhaps, some of your mates who perhaps refuse to follow up with the right principle of learning might end up in the lab not being able to do anything. And I've always advised and warned, in your normal weekly laboratory works, you do it as a group. Remember, in examination, it is you and you alone with the reagents. I repeat, it is you and you alone with the reagent. You don't do anything in groups. So I advise you, even if you belong to a group, please be involved in the process, in everything that is happening there, so that you can be learning all of this. Then, remember, GMAT 41 has got your back. If you follow up with this platform, whether a physical tutorials or online platform, become a channel member. I will guide you. I'll teach you everything you need to know. Go to the lab, you play with those things, because you already know what you'll be expecting in the observation, as the case might be, and what you will conclude, because you have the theoretical background already. All right, I think I've advised you enough regarding this. Let's move on. The alternative consideration from this number 2 is now a situation where, let us assume you have that solution of the sample from here, But when you tested with pH indicator, you found out that there was no effect on red litmus, there was no effect on blue litmus, which means that the litmus paper remained unaffected. What will be your conclusion? Because this is still possible. It is still possible. Remember, we are still working with solution from number 1 above. So, I'm going to come here. I think this covers up to this point. Let me check the coverage. Let me check the coverage to be sure that, nothing cuts off. Okay. Let me see. Trying to see where I would write from. I think I can write from here. Test, observation, and then inference. Inference. You know that what we are doing now, both in your exam, it is going to guide you, because some of you will be exposed to solubility tests in your exam. So let's look at the alternative consideration to what we've done here. That I am going to consider as 2B, 2C rather. Once again, from what you saw happened in the first case. So it's going to be solution from 1 above. From 1 above, now plus pH indicator. pH indicator. I have told you that the pH indicator we are going to be using is litmus paper. So let us assume that there was no effect. Let us assume that there was no what? Effect. So no effect on litmus. No effect on litmus paper. On litmus paper. Of course, it is advisable that the litmus paper should be damp. So before you dip it into that solution from this, possibly you can wet it a bit with distilled water. You can wet a bit. It will help for the reaction to be fast, if there will be a color change or not. So just dip into distilled water a bit and then you proceed. If this is what you observed, then that unknown organic sample will be said to be neutral. So I'm going to write sample is neutral. Sample is neutral. Sample is neutral. And if the sample is neutral, what homologs are possibly there? For the fact that the sample is neutral, we can suspect the following homologs. So we can say that the sample, so it could be sample A or B. The sample could be, now I'm going to write the functional groups here. I won't write their names. When I write the functional group, I'll tell you the names. So COR, could also have COOR. We could have CONH2. We could have ROH, or all these guys are of low molecular weight, or this could have been an alkane, or okay, let me use comma, this one or this one. Don't worry, I will tell you the name of all these homologs. They are functional groups. Please don't take your Chem 102 for granted. I know that some of you have not even started the lecture. But GMAT 41 is already in progress. We are moving. Even today, we have our Chem 102 tutorials, right? Later today, like I said, you register for our physical tutorials so that GMAT 41 will guide you. You can also apply for our online class, become a channel member, and follow up. So the fact that this solution here, that sample that you are testing for, maybe you found out that the sample dissolved in water as we have in number 1 here, and we said it simply means that the sample is polar. You now went ahead to do your second test, pH indicator. Maybe you dipped your red and blue litmus paper simultaneously into the solution, and then you found out that none of the litmus paper was affected. None of them changed color. They remained the way you had them initially. It simply means that that sample you are testing for is a neutral sample, a sample whose solution is neutral. That is why it did not affect litmus paper. Once this is the case, these are the various things that you can suspected. Yeah, these are the various things you can do what? Suspected. We use suspected because there are more than one of the things we are thinking likely should be there. This is the functional group for alkanal, aldehyde, alkanal, the same thing. This is the functional group for ketones, right? You can call them alkanone also, following IUPAC, naming or system. This is the functional group of esters, alkyl alkanoates. I've treated all of this in Chem 102, like I said, in our online classes. This is acid amide. This is alkanol. So any one of these guys could have been the organic compound you are testing for. And all of them are of low molecular weight, because that is why it was able to dissolve in water in the first place. For higher molecular weights, right, of these guys, it won't dissolve. But we are testing towards, the direction where we assume that, okay, fine. Maybe when you are testing for either A or B, you found out that the sample dissolved in water. So this is what will likely happen when you do your pH indicator test. Now, this could also be alkane. It could be alkene. It could be halogenoalkane. This is halogenoalkane. That is alkyl halide. That's another way you can call it. So any one of these guys could have been the organic substance you are testing for. So suppose it is A now you are testing for, because here I am not specifying, I'm not using A or B or C or whatever. Like I say, it's a general consideration, so that whatever you are testing, whatever it is being labeled, you follow that label. If you are seeing this reaction, you know this is what is there. So assuming out of the two samples you likely be presented with, let's say sample A or B. Using sample A, for example, you dissolve it in water, you found out that the guy dissolved. That is, sample A is soluble in water. You make this conclusion that sample A is a polar organic compound. Then you now go ahead in your second test, pH indicator test. You dipped your litmus paper blue and red, and then you find out that nothing happened. No color change. It simply means that sample A, which is that organic compound there, is a neutral sample. It's an organic compound that is neutral. That is why it didn't affect litmus paper. So you now make a conclusion that sample A is neutral. Sample A is likely. That's why I say could be. It's likely. You list all these things. Suspected. Does that make sense? So we've been able to analyze all these things in the direction of assuming that, okay, maybe that sample, when you dissolved it in water, it was soluble, making it polar. If it is sample B that behaved like this, fine. All these things you are seeing, you use sample B as your definition, which means in this case, sample B plus water, you found out that sample B dissolved in water, write the observation, make this conclusion, sample B is polar. Then in your second test, you want to check for pH indicator test as to whether the guy is acidic, neutral, or alkaline. You now found out that the solution of that sample B did not affect litmus. You will conclude, right? Okay, solution of sample B had no effect on litmus paper, did not affect litmus paper. Then you now conclude sample B is neutral. You write all these things. So you want to bear this theory in mind. Now, dear friends, we are done with the summary analysis of a given organic sample when you are working with, polarity test of that guy using water and using pH indicator. In a case where possibly the organic sample given to you is soluble in water. These are the possibilities when you carry out further tests on it. What if it happens that the unknown organic sample, either A or B as the case might be, you added water to it. It now happens that the sample did not dissolve. It happens that the sample did not what? Dissolve. What would you do? I know you would like to know, is that not so? That's good. We are going to move on. We are going to move on. So I'll wipe this part. I'll wipe this part. I'll wipe this part. Mind you, the direction we are now going is a situation where it is observed that the organic sample you are testing for, that A or B, as mentioned in the instruction I read. Suppose you found out that the guy did not dissolve. How do you analyze the stuff? All right. So I'll adjust the camera to the other side of the board. Let's start again. Remember to share the link of this live class to your friends, right? Share the link to your departmental WhatsApp group. Those that are free and can connect to the class should connect. Do not waste your time, for you don't have time. Let me make a little demarcation here. Good. So let us now analyze this towards the direction of insolubility. Okay, so we want to assume that the sample given to you when you dissolved it in water, it was not soluble. So what are we expected to do? What is going to be the analysis? So we go back. I'm going to start again from number 1. Unknown sample. Unknown sample. I think I've got to adjust this line a bit. Unknown sample plus water. So we now want to assume that it did not dissolve. The sample was insoluble in water. Like I said, when something is insoluble, it means it did not dissolve. The fact that this unknown sample, it could be sample A or sample B. The fact that it did not dissolve in water, it is insoluble in water, simply means that unknown sample you are analyzing, you are testing in the lab, is a non-polar organic substance. So the inference here will be the sample is non-polar. The reason is because non-polar molecules, non-polar substances, organic compounds that are non-polar do not dissolve in water. That is a general rule for it. So if it happens that you're carrying out your test, maybe you found out that with A, when you added water, it didn't dissolve. Then you will conclude that A is a non-polar organic compound or molecule, whatever you want to write there. So the sample is non-polar. Okay? Let me add non-polar organic compound. Because of course, it is organic compound test you are, carrying out. If this is the case, what can be done? What can be done if this is the case? So we're going to move on. Further testing will be required. Further testing will be what? Required. The fact that this guy is insoluble. Further testing will be required. In fact, from here, there are so many things, you can suspect. There are so many things you can do what? Suspect for the fact that the guy is insoluble. Do you understand that? There are so many things you can suspect. You can suspect a mean of high molecular weight. Take note now. High molecular weight. Remember the other one we saw when it's dissolved, when it was soluble, is that which has low molecular weight. So in this case now, where the sample did not dissolve in water, you say that the sample is non-polar. Possible things, homologs, to suspect would include a mean of high molecular weight, carboxylic acid of high molecular weight, aldehyde, ketones, esters, alkanols, acid amide of high molecular weight, phenols, that is hydroxyl benzene, right, can also be suspected in this case. But don't worry, let's move on further. When you find out that the sample is insoluble in water, like I said, further testing would be required. And you test using the solution from here. So this will now take us to number 2A, because something might happen in the second test that will still warrant you to carry out further tests. Am I communicating? As a matter of fact, let me just list the reagent likely you use in this case. When you find out that the guy is insoluble in water, reagents like hydrochloric acid, dilute hydrochloric acid, dilute sodium hydroxide, dilute sodium hydrogen trioxocarbonate 4. These guys are now reagents used for further testing. That is why you were presented with those reagents in the instruction that I read. That is why you were presented with the instruction that I read. William Scully, you are funny. NDBC, what do they find? NDBC is finding what you're also finding now, right? You don't hurt, Abby. You are so funny. All right, all of you, you are welcome to connect into the class, and I hope you are learning something. Please do not play. Don't joke. You see, this semester practical, the truth is, it is a bit tougher than Chem 107 of first semester. Let me just be honest. If you've gone through your works, the manual given to you in this Chem 108, you know that it's really not going to be funny. Yeah. But it doesn't mean that it's difficult. Why I said it's not really funny is this is the first time some of you are getting exposed to this organic compound test. But GMAT 41 is there to carry you all through, and you can always count on GMAT 41. Okay, please support this channel, become a channel member. I'm saying it now because most of the key lecture videos are usually logged on YouTube, right? So you become a channel member so you can access all of them. You can also join our physical tutorial class. I am saying this and making it clear. Like today, we have a physical tutorial on Chem 102. That is organic chemistry class. That course is completely linked into your Chem 108. So you don't joke with it. Okay? Now let us move on to further testing. So in the further test, 2A, you will be required to add hydrochloric acid. So you add like 5% hydrochloric acid to the solution from one above. So it's going to be solution from one above, all right, plus 5% HCl. 5% HCl, dilute hydrochloric acid. So if you add 5% dilute hydrochloric acid, and then you observe something, because here now we are going to make two assumptions. One, the solution dissolved. This is soluble solution from here, dissolved. What will you infer? Okay, what about the solution, the insoluble solution from here? On adding 5% HCl, you found out that it did not dissolve. When it does not dissolve, what will you infer, conclude here? So we will go in two different ways, right? But one after the other. Let us assume that on adding this 5% hydrochloric acid to this solution from one above, which is insoluble, you found out that the insoluble solution from one above dissolved, became soluble in HCl. what will now be your inference? Let's go in that direction first. The insoluble solution. The insoluble solution from 1 above dissolved in 5% HCl. Now this shows that the sample, so if it is sample A that behaved in this manner, or sample B that behaved in this manner, this will be the inference we write. The sample is a mean of high molecular weight. High molecular weight. I'm abbreviating this MW. You can write it full if you are in the laboratory. All right. So the sample is a mean of high molecular weight. Or you can say a mean of high molecular weight present. That's another way you can present it. A mean of high molecular weight present. Maybe let me present it that way. Okay, because we'll be using the other format. It doesn't matter. You can write any of those format or use any of those approach. A mean of high molecular weight. High molecular weight present. Okay? And the functional group there is RNH2 because RNH2 is the functional group. Okay, I thought I have it here. Is the functional group of amine. All right, so you can even write it in bracket. I don't know. I hope this does not cut off. But if it cuts off, what will I do? I want to write the functional group for you, so that if you don't wish to write it full like this, amine, you can also use the functional group. Good. Of high molecular weight present, because this is the guy that behaves in this manner with dilute hydrochloric acid. So we are now assuming, now look at what we try to summarize here, because like I said, I'm giving you the key to unlock whatever you see in your solubility test of organic compounds. In that sample A or B, likely that you'll be presented with, the sample can be changed. It can be labeled sample C and D, whatever, E or F, whatever the case is. You dissolve, let's say, the sample A in water, and you find out that sample A is insoluble in water. That is, did not dissolve in water. That shows that sample A is non-polar organic compound. So you write A is non-polar organic compound. If it is B that behaved in that way, let us assume when you're testing for B, you found out that B did not dissolve in water. Then what you write here would be that sample B is non-polar organic compound. So I am saying, whether A or B, any one of them that behaves in this way, this is the inference you write. Then you go further to further testing, because you need to find out what really might be there. You were asked to classify the compound, their homologs. And this, you use these guys to classify them. That's what we're about to do now. If you add 5% hydrochloric acid to the solution from one above, and then you find out that the insoluble solution from that one above dissolved. Let's assume you're working with A. And now find out that the insoluble solution of A from one above dissolved in the second test with 5% HCl. You will now conclude that sample A is a mean. Okay, I think you have to write that at the end. Say a mean of high molecular weight present. They can now write sample A is a mean, because you're now telling us that's what is there. Right? A mean of high molecular weight present. Sample A is a mean. If it is B that behaved in this manner, you follow the same format, but you now be saying that sample B is a mean. What if you now get the point? We're now looking at a situation that, okay, in carrying out this second test, by adding 5% hydrochloric acid to the insoluble solution from above, whether it is A that behaved like this or B, what if you add 5% of HCl to that insoluble solution from one above? And you now find out that the insoluble solution from one above did not dissolve in HCl. That is to say, the insoluble solution from one above is insoluble in 5% of HCl. If it is insoluble, that is to say, it did not dissolve, would you go and make this inference? No. Because amine won't behave like that. Amine will dissolve. Are you following, right? That's what you have here. So if it happens that a solution from above does not dissolve in 5% HCl, it simply means that the organic sample, whether A or B, whichever that behaves like this, is not amine. Further testing will be required. If it is not amine, there are various things you can suspect. If it is not amine, there are various things you can do what? Suspect. And that is what we now want to look at. But instead of me to wipe this and then say, let's now look at the or, I won't wipe this because I want you to see all of them. As you read through, you get prepared. When you go for the lab work, you know what to do. So assuming this will now be 2B. So this 2B normally is what should be here if maybe by the time you test with 5% HCl, the insoluble solution from 1 still did not dissolve. This is what you're meant to write in that case. So 2B, solution from 1. Solution from 1 above plus 5% HCl. You now find out that the insoluble solution from 1 above did not dissolve in 5% HCl. Good. When this is observed, what is happening? Is network disturbing? I hope network is not disturbing you from your end. I don't know. This is trying to hang. This is hanging somehow. Okay. All right, let us move on. So like I said, if on using 5% HCl, you find out that that insoluble solution with water from above still did not dissolve. This would be your inference. COOH let me write phenol first. Phenol, C5, right? C6 rather. C6, H5, OH, comma, COOH, comma, CHO, COR, COOR, ROH of high molecular weight. Of high molecular weight suspected. I'm going to wipe this part of the board. Or let me adjust the camera and finish up what should be there. Okay, I think it's showing. Of high molecular weight suspected. I could have written them straight since the whole part of the board was captured. So I'll have more space because it's something else I need to write. So COOH, CHO, COR, ROH of high molecular weight. Permit me to use HMW for it. high molecular weight, or it could be alkane, alkene, or RX. That is alkene halide. Suspected. Right? That is what to be suspected in that case. Whereby the solution from one above, right, does not dissolve in 5% of HCl. It is these guys of high molecular weight that are suspected. I've told you the name of these other ones. Look at this C6H5OH is phenol. Phenol, P-H-E-N-O-L. Phenol is also known as hydroxyl benzene. Benzene that has OH in it. All right, I'm going to wipe this part. We continue with our analysis. In a situation where this is observed, further testing will be required. In a situation where this is observed, further testing will be required. I hope you're following, right? The solution from 1 is still insoluble in 5% HCl. Further testing will be required. So I want to do further testing. Here, sodium hydroxide will now come in. Sodium hydroxide will now do what? Come in. And let me tell you something. The solution you are going to use in that case will come from 2B. That solution you want to use to carry out further testing. To be able to know actually, okay, out of this whole thing, what are the things likely present? The solution now will come from 2B. From that one you applied or you added 5% sodium, 5% hydrochloric acid. Excuse me. Let me check what is happening at that end. I hope this is still on, okay? All right. Trying to monitor what is happening there. Let it not be what used to happen sometimes. By the time I've spent all my time, maybe network will just obstruct everything. All right, we're going to use this part of the board now. So I will adjust the camera. So let's see what we've got. Good. So like I say, further testing will be carried out to see what we have there. Now we're going to test using sodium hydroxide. 5% sodium hydroxide will now come in. So I am going to write. This will now be, let's say, 3A, solution from 2B above. Solution from 2B above. From 2B above. Plus 5% sodium hydroxide. Good. Plus 5% sodium hydroxide. So in this case, again, there is an alternative. It is possible for the sodium hydroxide to dissolve this solution you have from here. It is also possible that the sodium hydroxide does not dissolve what you have there. It is possible that it does not what? Dissolve what you have, the solution that you have here. So we are going to look at that alternative. Do you understand? We're going to look at that alternative. What if the solution from here dissolves in sodium hydroxide? What would now be your inference? What would be your inference? What if the solution from 2B here, where you added a 5% hydrochloric acid, what if that solution does not dissolve when you add 5% of sodium hydroxide? What if it does not dissolve? If it does not dissolve, of course, you know your influence will be different from what you would write when it will dissolve. Now, this is what I am going to do, right? First, we're going to consider that the solution from 2B above did not dissolve. It did not dissolve, because that can help us get exactly maybe what is there. Then we'll now look at a situation where it dissolves. We'll now look at a situation where what? It dissolves. Right? Or let's take a situation where it dissolved first. And then we'll look at that which it did not dissolve. So let us look at that which the solution from 2B dissolves. So I'm going to write solution from 2B above plus 5% sodium hydroxide. Solution from here plus 5% sodium hydroxide. The solution dissolved. The solution dissolved in 5% sodium hydroxide. The solution dissolved in 5% sodium hydroxide. Now this is what is going to happen. Out of these plenty things, right? This whole thing you suspected. For the fact that sodium hydroxide now dissolved the solution from here. Out of these whole homologs, these whole organic compounds, what will be there will be phenol or carboxylic acid. You suspect that. So I'm going to write phenol. Phenol, which is C6H5OH. And carboxylic acid, which is COOH. Suspected. The reason is because these two organic compounds, right, following this experimental test, will behave in this manner with sodium hydroxide. When you add 5% hydrochloric acid, that is dilute hydrochloric acid, to the sample, right, the solution from wine, you add 5% hydrochloric acid and you found out that that insoluble solution from test number 1 did not dissolve. It's insoluble. You suspect all these things. Go further now. Use the solution from 2B here. Add 5% sodium hydroxide. And you now find out that the insoluble solution from this 2B, when you use hydrochloric acid, that insoluble solution now dissolved, now became soluble in 5% sodium hydroxide. It means that out of this whole thing you have here, it is phenol or carboxylic acid that is actually there. Yeah, that is somehow there. So you need further testing to determine, okay, out of these two, which one actually is there? Out of these two, which one is there? Which one actually is there out of these two? You need further what? Testing. And at this point, sodium hydrogen trioxocarbonate 4 will now step in. Sodium hydrogen trioxocarbonate 4 will do what? Step in to help us know what exactly is there out of the two. And that sodium hydrogen trioxocarbonate 4 you are going to add. You will be adding it to this solution. So I'm going to write 3B. Solution from 3A above. 3A above plus 5% sodium hydrogen trioxocarbonate 4. Solution from 3A above plus 5% sodium hydrogen trioxocarbonate 4. The solution from here that made us suspect just these two homologs. If you add sodium hydrogen trioxocarbonate 4 solution to it, and you observe that in this case the solution dissolved, right? You now observe that effervescence occurred. You observe that effervescence occurred If effervescence occurred, then it tells us something. It tells us something. I'm trying to get the solution we use in this case. I'm trying to guess the solution we use in this case. Right? The solution we use in this case. All right. So I use the 3A from here. 3A. That is when it was soluble. When it was soluble, this is the solution you use. It's very important to know particularly the solution that you are using to carry out this test. All right. So on adding sodium hydrogen triiosocarbonate 4 to this solution, let us assume that effervescence occurred. Effervescence occurred. Effervescence occurred. Effervescence occurred. And the solution dissolved. The solution dissolved in 5% of sodium hydrogen triiosocarbonate 4. In 5% sodium hydrogen triiosocarbonate 4. Let me pick a new marker. So this will now tell us, out of these two compounds, these two homologue, what will now be there is carboxylic acid. Carboxylic acid, in bracket COOH, present. Which means that sample A or B, as the case might be, remember the sample will be labeled. So whatever the sample is that showed this behavior, this observation, whatever that sample is, if it is sample A that went through all these, down to this point, it means that that sample A is carboxylic acid. Right? Okay. What if it happens that the solution did not dissolve or there was no effervescence? If there was no effervescence after you added this. So I'm going to write here. Let me write something here. Otherwise, I will explain that. Otherwise, then I'll link it up here. Phenol in brackets C6H5OH present. I'll tell you the meaning of this otherwise. Please do not go and write any otherwise in your report. Don't. This thing means suppose this does not happen. Because we are trying to now differentiate, find out of these two compounds which one is actually present in the process or in the sample. Which one is the organic sample given to you? A or B, any one of them that followed or showed this behavior, this observation. At this point now, we are trying to find out which one of them out of the two is actually either phenol or carboxylic acid. If effervescence occurs, that like when you open your Coke or Pepsi or Sprite, you hear that that is effervescence. If it occurs, right, it simply means that carboxylic acid is present. Otherwise, that is to say, if effervescence does not occur, it means that carboxylic acid is not there. That what you are now likely left with could be your phenol. That would be the implication of the process. Now remember, where we started all this from is from 2B, where the solution from one above is insoluble in 5% HCl. That required further testing using sodium hydroxide. We use sodium hydroxide and we said, okay, what if you find out that the solution from here, because testing with sodium hydroxide, the solution you are now using is that from 2B. All these things are very, very important. You should know the solution you are meant to use. Because in your exam, for example, examiner can just present you with a sample and then tell you, okay, you have this organic compound, you have this organic compound. Present your report on how you can identify them in the laboratory. So you should know the pattern you follow and the sample you use to carry out your test. So whenever you're using this sodium hydroxide in the process, the sample you are going to use to test with sodium hydroxide, that sample is that from which you made use of hydrochloric acid, where the guy did not dissolve, right? Where that sample did not dissolve. Using that hydrochloric acid, the solution you got from here, which did not dissolve in that hydrochloric acid, that is what you would use to test with sodium hydroxide to know what happens. All right. And you notice that in this case, we say with sodium hydroxide, we assume that the solution dissolved in 5% sodium hydroxide. If this is the case, you are suspecting phenol and carboxylic acid. So all these things you're seeing out of them, the ones I wrote there, there were many, you know, phenol, alkanoic acid, that is carboxylic, aldehyde, ketones, esters, acetamide, alkanol, because those are the things we suspected when we used that hydrochloric acid. And then we say it did not dissolve. Using sodium hydroxide now to test that particular solution, if the insoluble solution there now dissolves, it simply means that you have phenol or carboxylic acid in it out of the whole list. Then further testing using sodium hydrogen triisocarbonate 4. The solution you will use is no longer that one of hydrochloric acid. Rather, the solution you are going to use is this. Because these two guys dissolved in sodium hydroxide, you want to use 5% sodium hydrogen triisocarbonate 4 to differentiate between them, to know actually what is present. And from what you see here, if what you observed in the laboratory is such that on adding 5% sodium hydrogen triisocarbonate 4 to the solution from 3A above, you now observe that effervescence occurred. If effervescence occurred, then carboxylic acid is present. Yeah. But otherwise, I've told you don't write otherwise. Like now I said, effervescence did not occur. Effervescence did not occur. If effervescence does not occur, then you know that it is not carboxylic acid that is there, but what? Phenol. Which simply tells you that this sodium hydrogen triisocarbonate 4 is actually used to check for carboxylic acid. All right, we should work towards rounding off now. We should work towards rounding off. We have done a greater work there. It's just left with only one thing. And that one thing is, what if in this test, we are done with this, I'll adjust the camera. I will adjust the camera, but before adjusting, I want to show you something. Let me just turn this way, because I still have space under there. Oh, let's go this way, no problem. We use this side of the board. All right, so take a look at this solution. Take a look at it. Remember, it was this solution from 2B that you added sodium hydroxide, you know, on the other side of the board, which we said it dissolved. Sodium hydroxide dissolved the solution from this 2B. Observe once again that the solution from this 2B was the solution you obtained when you added 5% hydrochloric acid to the solution from one above, where you used water to check whether the compound will dissolve or not. From this solution, perhaps it is like, okay, we divided this solution into two. The first portion, we use sodium hydroxide, 5% of it to test. The second portion of this, I'm sorry I did not indicate first portion from 2B above. I think I should go and indicate it, because we are meant to divide this possibly into two. Are you following? Or it doesn't matter, I'm saying it so you have all this idea. This solution possibly will be divided into two. You test one in the direction of solubility, in the direction whereby this insoluble solution will now dissolve. That is the direction where we use the reagent sodium hydroxide as well as sodium hydrogen triisocarbonate 4 to help us confirm the presence of either carboxylic acid or phenol. And in the observation there, you remember that when you use sodium hydroxide, that sodium hydroxide dissolved the insoluble solution from 2B here. So my question will now be, what if in the lab, as you are carrying out the test, you added 5% hydrochloric acid to the solution from 1 where you dissolved the unknown sample in water. You found out that the insoluble solution from 1 above did not dissolve in hydrochloric acid. You now went ahead to make use of sodium hydroxide to see what is going to happen to the insoluble solution from here. But this time around, the insoluble solution refused to dissolve. That is to say, it did not dissolve. What would you suspect in that case? So I am going to wipe some parts of this side of the board, at least this 1 and 2. I'll wipe it so that we can conclude. I'll still leave this because I'll make reference to it. No, it's been good. A long journey, isn't it? What I've done here is complete solubility test analysis for organic compounds. It's a serious work that I've done here to guide you through your works, right? Because you might be tested on solubility stuff anytime, and even in your exam. Specific solubility test. Like this one you are going for is a specific solubility test. Maybe you just test for 1 or 2 of those organic compounds. You may still do solubility test next week. It's possible. Anything is possible. But let's assume you don't even do it in your exam. All these plenty things I'm doing, you can be tested in any direction or ask questions in any direction. Like I said, this is what is going to guide you in your laboratory work, especially for those that are taking their own practical work from tomorrow. Okay, so this is going to be 4. Number 4. And now number 4, this is what I have. Solution from 2B above. Solution from 2B above plus 5% sodium hydroxide. So look at this solution, which we use to analyze and confirm the presence of carboxylic acid or the absence of carboxylic acid. Or perhaps, which we use to confirm the presence, are you following, of phenol or the absence of phenol. You remember when I talked about effervescence occurring? Good. Or not occurring, the otherwise stuff. Remember that in that case, the insoluble solution from these 2B dissolved. In the case of sodium hydroxide, confirming phenol carboxylic acid. So what if the insoluble solution from 2B now does not dissolve? So we are saying maybe second portion of this. So I'm going to write it much more clearly for you to see, in a way you'll understand it. The insoluble solution from 2B above did not dissolve in 5% sodium hydroxide. Good. In the other approach, we assumed that it dissolved. It dissolved. So this is what you would write as your inference. Now, what if it does not dissolve? So let us come back to what we have here in the case, when we made use of 5% hydrochloric acid, we had all of this suspected. We now made use of this solution, added 5% sodium hydroxide, assuming that the sample you are now using, when you carried out this test, you found out that the insoluble solution from this 2B still did not dissolve when you added 5% sodium hydroxide. Good. It means that phenol is not there. Carboxylic acid is not there. Are you following, right? That these guys are not there. And if these guys are not there, these two guys, phenol and carboxylic acid, you are left with the other, homologs. Please take note that these homologs here are those of high molecular weight. Those of low molecular weight, in fact, when you add them to water, they will dissolve initially. We are done with that, okay? So in this case, I'm going to write CHO, comma, COR, COOR. I've already told you the name of this homologue. Then CONH2 is also there, although I didn't write it here because I was struggling with space here. That is the amide group, amide, of high molecular weight. High molecular weight. Suspected. Suspected.